Okay, thank you very much. Welcome everyone from my side as well. If today my voice has a bit of a strange sound, then this is caused by a bit of cold, but I hope it will carry me through today's lecture. And again, thank you very much for inviting me for the talk today. I was trying to illustrate us getting started with a couple of visuals, because our discipline, geoinformatics, clearly is a very visual discipline. This is the way how we communicate. And this is one of the USPs from one of the unique characteristics of our discipline. And the pictures you can see right now, they are chosen to illustrate the diversity in terms of scale, global, regional, local, the diversity in terms of different perspectives, so flat, plan, or 3D, and of course, multiple topics. So when discussing where we are going, talking about trends, I just noticed I was adjusting the title just a little bit, but I hope you don't mind with that. And the key word here is with talking about our future, all of our future with GIS, not the future of GIS. This I would like to emphasize. And as you will notice within the next few minutes, I will not focus so much on technologies. I will even put maybe the one recently evolved technology on the back burner, which maybe you would expect me to focus on. Because my perspective is that if we want to, in the future as well, leverage the full potential of geoinformatics or GS as a set of tools, then it's not so much the technology, but it's people's minds. So it's an instrument where we can translate spatial thinking into action in a personal context, in a societal, environmental, in an economic context. So over the past millennia, going back, spatial thinking clearly was a survival skill. For instance, having to decide when to run away or stand up against some danger. And that has evolved into, survival skill on a societal scale. Spatial thinking today is critical for supporting decisions we all need to take, again, as individuals regarding our environment, our livelihoods, and beyond. So again, I will not focus too much on technologies today. I take it you are all familiar with this famous DIKW pyramid, where we go from the bottom to the top, increasing the value of what we have. In our discipline, we are very much focused on data. When we got started decades ago, maybe quite many decades for some of us, data were scarce. We had too little of them. And we were spending a lot of effort on acquiring the data we needed for one or another project. That has changed completely. We are today inundated by data. And that means as well that the focus on what we are doing with GIS is changing, and it keeps changing. So with spatial analysis, we create more value. We create information from data. When we're asking the right questions, then we apply knowledge, and sometimes we even get to the very good decisions with the wisdom on the top. Translating this into the questions, where increasing value is being leveraged, then we start from the very traditional what is where questions, which were unfortunately for too long associated with the discipline of geography, which is the home discipline for many of us. But of course, we need to move on from the what is where to the explaining, to the why is it there. And then we follow that up Why do we care? So why is it important for us? So this sequence of what is where, that's the mapping. Why is it there? That's spatial analysis with the purpose of explaining. Why do we care? That's applying in a wider context of one or another. That can be a business environment, that can be a societal or environmental application. And it's no coincidence I've put the SDG logo on the top left, and I will mention this a little bit later again. So again, starting where we came from a few years ago, and some of us might recall the early textbooks of GIS, where in the introductory chapter, there was a discussion of the definition, what is GIS, and typically they are presented as systems of hardware, software, data. That's the big bulb here, right in here. And then the organization in an institution and the people and the knowledge of people. That has changed again, and it keeps changing. And unfortunately, the textbooks really don't really follow suit. They are sometimes lagging a bit. So that's why it's important to focus that on the fact that hardware, software, data, first of all, are not completely distinguished from each other anymore. At least not from an end user perspective. And they are what I call the technology, the techware, which is cloud-based. And I'll mention the focus on cloud a bit later. And then it's the people. So it's the technology and the people. And what I call the brainware here is sometimes and increasingly perceived as being a shortage in our disciplines. And it's interesting to observe that we talk about smart buildings or smart cities, smart everything. Actually, I believe we maybe should reserve the term to the case where people are involved, because that's what's sometimes lacking in the, just referring back to the spatial thinking paradigm. Another aspect, which is a development already reaching back anywhere between 10 to 20 years in our past. Originally, geoinformatics and GIS was emerging from a few root disciplines. Certainly geography and its flavors, cartography, sometimes cartography combined with cadastre, with land management, with documentation of the land, and that again linked to surveying and surveying engineering. And that was pretty much it in terms of the geospatial or digital geospatial disciplines. Well, now today, and this diagram is actually from a survey done by a geospatial marketing company. You can see the logo on the top left-hand side, where they were exploring the markets in terms of market volume, so in terms of dollars or euros worldwide. And you could see there is very little mention of geo. I think there is fundamental geospatial on the bottom right, which I guess is a reference to cadastre and base maps. But essentially, it means that geoinformatics today is used by pretty much everyone. Certainly is being used by more discipline, by more subjects than not. And it's a heavily trans-disciplinary topic as well. So while academia and sometimes business is organized in silos, in little boxes, and today we would be very well advised to do away with this form of organization, because in the earlier years I've observed myself in one or another university, including mine, that there was more than one department, more than one institute, and the same applies to business entities, to larger enterprises, different entities within the same enterprise, within the same university, where GIS was used, was invented, was reinvented, and double implemented in one or another case. And the actual main advantage of a spatial view, of a spatial perspective, very clearly is to consider that a kind of transversal competence and transversal technology, an enterprise level or maybe a university level entity, not only at home in one department or maybe in a few departments, but supporting the spatial approach, the spatial view by everyone. Right? So, oops, was jumping over that. Another, and there's 2 or 3 more of these major paradigms I would like to introduce, is the paradigm of a macroscope. This actually would be a nice video. I'm not going to play it to you here due to time constraints, so you can just look at the video yourself. If you search for macroscope on Vimeo or another well-known video platform, you will find it. And it's not a typo, right? So, and again, that demonstrates how much geoinformatics is used and is of good use in different disciplines, is just as a counterpart to the microscope, which we use in disciplines, we use for tasks, where we want to dig down deeper into more and more detail. We want to see a detail beyond the level of resolution of the human eye. The macroscope is the opposite. It again goes beyond the capacity of the human eye, but not looking in minuscule detail, but looking beyond the horizon, establishing wider context for what we are doing. And this basic concept of the macroscope, and the satellite image is a macroscope, a map of a scale 1 to 100K would be a macroscope, a development plan of a municipality, all of these would be macroscopes as a kind of family of tools. Then another thought I would like to share is one many of you may have heard from me or may have come across. And this is without advertising the company where this is the mission statement. It's still, I believe, a very valuable thought. The Google mission statement would be one word less than what you can hear right here on the screen. It is to organize the world's information and make it universally accessible and useful. Yeah. And of course, we relate that to search and finding and being able to access all kinds of data which translate for us into information. Now, when Google acquired their spatial component, they just added one word to that mission statement. They inserted the term geographically when they started to work with what we today now know as Google Maps, Google Earth. Back in the old days, it was the Keyhole platform, which some of you might still recognize from the KML acronym, the Keyhole Markup Language, where this older product identity is still maintained. So when Google started to get into the spatial domain, the ultimate purpose was not to provide free maps and free navigation. Even so, maybe we would appreciate this most in our personal or daily lives. They inserted the term geographically. And for the Google Spatial, Google Earth, Google Maps domain, the mission statement now reads to geographically organize the world's information, make it universally accessible and useful. And what I would like to point out here, they're not talking about geographic information. It's not geographic information on one side, and whatever that might be, non-geographic or non-spatial information on the other side. It's geography, it's spatial organization as a fundamental principle for everything and everyone. You remember on the previous slide, these many slices of different disciplines in the pie chart. For everyone, for each and every one of these disciplines, it's important to have a geographical perspective, to be geographically organized. And this is I believe, very important leading thought, which is not new. So maybe you would hold me to the title and say we talk about the future, we talk about the trends. It's a bit more the call to action to start and keep thinking along the lines of what this very valuable paradigm actually says. And it's very well illustrated, right, by the mystic of the blue dot, because this blue dot is very familiar to us, and it's data, but it's not information. It only becomes information to us when we contextualize it, when we put it into the context of the broader realm of spatial data and information. Like the dot as such has no real value, only in the context, in combination with spatial context, it would help. And this blue dot today is typically generated by one of these many mobile devices we're working with. Again, that's not future, it's presence. And I sometimes like to compare the smartphones with the Swiss Army knife of geography and beyond. Swiss Army knife is a metaphor for a universal tool. And we all are aware what we can do with these tools beyond just generating the blue dot. We use it like on the bottom right for the mundane daily task of navigation. We can use it for augmented reality applications by exploring our environment with one of my favorite apps, the Peak Finder app, and there are similar ones. So it's now gotten into everyone's hands, so to use the more familiar metaphor, at all of our fingertips. But sometimes, and this is certainly one of the aspects which will be much more leveraged in the future, is the smartphone is not just a phone. It's even more so, or much more than just a phone. I personally use it, don't make phone calls every day, right? There might be several days going without me using the phone to speak to another person. On the other hand, there is very few hours during the day where I'm not using the phone to communicate or to access information one or another way. So the smartphones are extremely valuable and rich technology environments containing a lot of sensors. In our field, we talk about sensors and sensing all the time. We are familiar with remote sensing, with in situ sensing, with stationary and mobile sensors. And all of the time we observe, we generate data about something happening somewhere near the surface of the Earth. So all of these sensors support the ongoing developments we are today facing, whether they are just producing a location, like coordinates, or measuring many other aspects of our environments. Now, that's interesting, and it generates a lot of data. But if you just spend a few seconds exploring these vignettes on your screen, like the change of glaciers in Alaska on the top left, top bottom, the bird migration, in the center, the quite familiar environmental catastrophe of the near vanishing of the RLC, urban development in the top middle and in the top right, and on the bottom right, human population development regionally as well as demographically. So what's the commonality across these very, very different topics is that we combine space with time, working with spatiotemporal observations, working with temporal time series of spatial observations is something which has increasingly become available and valuable due to the ubiquity and the pervasiveness of sensors. That can be the 50 years of history with Landsat, giving us an excellent view on how the world is changing and has kept changing over the past decades. And of course, the same applies to demographics or physical measurements in one or another way. So while we are sometimes trying to present ourselves as the experts for the spatial view, I would just like to remind everyone not to skip the temporal dimension. Because life is change, our environments, our economies change all the time, and the dynamics of change are much more valuable indications of where we are going, of future developments, of future risks and trends, than just a static observation of one or another time slice. So going to the core of our discipline, in the beginning I had mentioned that we are a visual discipline, so we communicate spatially. So we work with geomedia, and geomedia is my favorite term of what used to be cartography. And I could discuss a little bit more why I'm using this term. I'm not abandoning cartography, but for the broader general public, maps are more like still considered or expected to be printed, or the digital on-screen equivalent of a printed map. And geomedia follow quite different principles. So that's why I'm using this term. So traditional geomedia, and I guess you would be familiar with each and everything on the schema, right? Depending on the globe, on the scale, depending on the scale, we work with a globe or a map. Depending on the view we are having with a map or aerial or satellite image. Sometimes we have collections of maps, which we call atlases. Sometimes very specific use, like city maps, road maps, or schematics, like at the bottom. Well, all of this, all of these purposes, all of these types of geomedia have made it into the digital domain. Also, they have changed a bit due to the different technologies we apply. We now have virtual globes, we have web maps, online maps. We have not only aerial images, but views from space, many of these per day. We satisfy particular purposes like the orientation or navigation with apps, mobility apps, and other ones, navigation apps. So if we go back here to traditional geomedia, I'd like to point you to the little sketch on the bottom right. So what was the real fundamental difference? Is it just these media, these types of maps in the widest possible sense, having gone digital? Well, it's a bit more. Again, if you look to the bottom right, there was a traditional one way, so unidirectional way of communicating. The cartographer worked with maybe a domain specialist and was encoding spatial information in a visual language, which was then transmitted to the reader, to the end user. And if the user was properly trained in map reading or map interpretation, much of the information originally encoded potentially arrived at the end user. Now, if you look again at the bottom right sketch here, that's turned into a bit more, something a bit more complicated. So just to compare, it's one directional communication, a sender and receiver principle. And now all of these arrows point in the both directions. And as we all have experienced, we cannot directly access digital data. So if I would pull a USB drive from my pocket and look at it, or do the same thing with a DVD or a disc, I could not, with my sensing, with my eyes, not read what's on it. So we always need mediation. We need a device in between. But again, this device is not only used for reading and transmitting, but these are interactive devices. So we can interact with all of these. That's where the most fundamental paradigm change in cartography and by proxy in our field as spatial communicators is coming from. And we still don't fully live that. So quite too often we are judging digital maps by the proximity to their analog counterpart. We, in many cases, in too many cases, are not fully leveraging the potential of interactive, dynamic, digital geomedia in all of our application domains. So, these media go into directions which some of us have explored, some of us will, with hopefully a little bit less top-heavy devices, will explore them in the future. And that means that we have immersive environments in augmented or virtual reality. And that, of course, brings us again to the point that we need to have the proper training, because navigating the world with these kinds of devices is kind of equivalent to the traditional map interpretation taught in schools and introductory university courses. Sometimes that goes into a more gaming-related environment, and some of you might be familiar with the augmented reality games like this one. And of course, it could go one step further. And some of you who are maybe had experience with Austrian landscapes, you maybe would call the top left vignette here Hallstatt in Salzkammergut, or maybe you think about Salzburg on the top right, and the Wachau and Dürnstein bottom right, and the high alpine Hohe Tauern landscape on the bottom left. Interestingly, this is one of the very early examples of AI-generated imagery. Like the prompt for that was create me a photorealistic rendering of Hallstatt. And as long as we used that prompt with a toponym, with a region where there's lots of photos in the internet, it worked quite well. And actually, this is an example from the very early days. It's about 2 years old, this example. And I bring it in here because I was talking about data, about observations, about communicating through geomedia. And when we think about the credibility and the believability of the data, we need to be aware that AI today has changed the rules of the game quite substantially. And talking about trends and future developments in our field, you maybe would have expected me to talk a lot about AI. There's actually 2 reasons why this is the only mention of that today. First of all, we talk about AI and its impacts all the time anyways, and many people do that. Many people do it much better than I can do. So I wanted to focus on a few other aspects. Secondly, you might have come across a quite interesting, very recent observation based on an analysis by OGC, the Open Geospatial Consortium, which came to an interesting conclusion that AI works well in non-spatial contexts. That might be a bit of a counter observation to what I'm showing right here. But what that means is that spatial relations, be that geometric relations or topological relations or directional relations, are not well manageable by AI yet. That doesn't mean it's not going to happen. I believe actually it's an extremely interesting research topic, but AI does super interesting stuff with documents, but not so much with relations. And much in geography is all about relations. So that was my only focus right here. So going to the final part of my talk, I just want to summarize that what pretty much all I had outlined before is based on one of the most pervasive trends. It's simply that the cloud is the computer. Much of those things are only possible or are favorably done on the cloud, on the network. And today, I myself, even though I would have desktop JS installed on all of my workplaces, I use it less and less, certainly not once a week. I use online JS many times a day. So this is a trend which is clearly something which carries us into a direction for what we need to know in terms of technology. And maybe you remember this techware and brainware separation I'm suggesting. So we need a browser, need a decent bandwidth internet connection, and then we need the brainware on top of that. We typically don't do lots of installations, local licensing. We just sign up to a portal. And this, and I had mentioned a few words on the Sustainable Development Goals as well, is simply the case because there is one world, right? And if you look at these three vignettes here, like on the right-hand side, more meteorology, climate, weather. On the top left, we would have maybe agriculture, farming, foodstuff production, and on the bottom left, we could look in hydropower and energy generation. So these are completely different silos. They are completely different disciplines. But very clearly, the common denominator is obvious. Yeah, this is weather, atmospheric circulation, it's water. So why would all of them have their own GIS? Why would all of them have their own data collection implemented? There is no need for that. That would be hugely ineffective. And we still do it to quite some degree. And this is one of the reasons why working in a cloud environment is, I believe, the decisive step to what's sometimes called modern GIS or next generation GIS. And we need to balance the livelihoods on our planet. When we try to measure the key life-supporting dimensions through the sustainable development topics, then we can do a lot of observation and debate there. But we need to have clear metrics to measure where we are going. Are we making progress? Are we reaching the goals? Are we even moving in the right direction? And all of this is done because you will be hard-pressed to find a lot of non-spatial aspects among the SDGs by spatial analysis, which is based on spatial thinking by exactly those, or at least some of those people who are living on the planet in the middle. And that brings us back to one of the key technology topics, because when we want to observe worldwide the progress in the SDGs, very clearly we immediately land in the domain of big data. And big data, that would be a separate interesting discussion, is, as we all know, not only defined by big means a lot, big volume. Yes, this is part of that, but it's, for instance, defined or described with the 6 V's, which is the variety, the velocity of the generation of data. I mentioned real-time observation with the sensors before, the value of these data, and again, we can only observe and monitor and keep track of our progress on the SDGs in a big data environment. But big data, that's not the one and all, yeah? Even when it's more than just a volume. What we need is to move over to the smartness domain, and that's again where the people come in. Yeah, you might remember my mention in the brainware context. This is something which obviously is restricted to data and people. And as much as we talk about artificial intelligence, the natural human intelligence still is not only needed, but I guess we want to have it maintain control. But again, we need to create more value. Think about the pyramid where we went from data to information to knowledge to wisdom, and underlie that the transformation from big data to smart information. And then we maybe end up with what sometimes is called digital twins, serving a range of different purposes, either in urban environments, in individual buildings, or wider environments. But one of my oldest kind of umbrella arguments why we are doing all of that is, again, the macroscope idea I had briefly mentioned earlier on. So there is the real world, and even though this looks a bit like there would be two, I believe we would agree there is no planet B out there. It's just an indication of the split in the discipline of geography into the physical, natural, and the built and societal environments. And that's where all the problems are. And we are using the digital representation, whether we call it a digital twin or a data model, I don't care so much, to better understand and hopefully to provide changes and to adapt our actions to these. And this is never linear. So this graphic clearly describes that on the left-hand side, where it's written observe, that's all the sensors where we observe the real world. But then we make sense of what we are observing. So that would be the data to information to knowledge track. And then, of course, we usually take action. We implement the plan, or we avoid taking a particular action, which is still a kind of action. Yeah. But we as humans change the surface of the globe all the time. And this is not, again, not a linear progression, because by changing the surface of the globe, it changes. So we have to observe the changes, which would be the monitoring and keeping track perspective I mentioned in the SDG context as well. So the good message here is we're not running out of work. We'll be busy with GIS, whatever is forever in the digital domain, but for a long time. So let me finish with what I would consider a few, and it's 5. I'm suggesting could be 3, I could be 10, but I made it 5. What you maybe want to consider critical success factors. Things, items which are not that much on the table of contents of a GIS textbook, but principles or paradigms or directions to keep in mind. So one of them would be openness. Much of the progress we have made in the last decade or two was driven by the principle of open. When the European Space Agency launched the Sentinel program and later on the Copernicus framework, it was pretty clear that data acquired under public European funding would be freely available. Well, this has changed the way how we observe our environments and societies substantially. And it had this nice side effect that shortly after, the Landsat imagery became free and open as well. So this is open data, but of course, open access to algorithms, open access publications, the Open Knowledge Foundation is something I'd like to encourage everyone to look into. This is a fundamental principle which really underpins the progress in science in general. But we have wonderful examples. like the one I just mentioned, in our domain as well. Or just think about the launching of the Galileo program with the free access in pretty good positioning quality. And after that, the infamous selective availability of GPS was quickly abandoned as well. The second point, excuse me, the second point I'd like to highlight is opening science really to everyone. I use the term citizen science of participating and sharing in the generation of knowledge. And the term participation or public participation is the participation by everyone in decisions in policy development. Why is this so important? Why do I put it in such a prominent place? Well, over the last few years, all of us unfortunately had observed that the credibility of science has suffered a lot. There is a lot of fakes around. There is not really a fundamental belief in scientific evidence. And we observe that day in and day out through all kinds of media. And that impacts our society directly, indirectly through elections and election results. And it's certainly a severe risk to democracy overall. So having many people participate in science, in the formulation of policies and public decisions, it's critical. And it's not a separate add-on all of us should do in our work, but it would be, I would say it's mandatory to make this a centerpiece and a core part of all of our work. Well, I talked already a bit about the progression from lots of data, big data with the additional characteristic to smart information and insights. And again, quite often when we do one or another project, we have an objective. We try to fulfill the objective by starting from observations, from data, from monitoring. We analyze these, we put them into context, and then we have results, and then we think we are done. Well, depending on kind of the scope we are applying here, again, I've used a circular graphic right here, because these insights, they lead to action, and then we start over again. So keep the principle of a circular flow of information, which hopefully is an upward spiral in terms of smartness and insights in mind. Very few of those GS applications we are working with are linear. One of the best examples, of course, might be natural resources and forest management, where some of you are coming from. In those disciplines, it was obvious that we are not working in a cycle only. Related to the citizen science participation, I believe we should focus on portals, whatever we do, make it available, make it part of a community of community insights. Portals are the user interfaces, and pretty much everyone is potentially a user for what we used to develop over the past 2 decades, which is spatial data infrastructures. Portals are the interface, and we should have started with development of portals much earlier. And the last of these kind of 5 critical success factors I'm suggesting, again, is the brainware aspect. And sometimes we think about that in a too narrow way, just in terms of, say, academic education, study programs, curricula. But on my lead-in slide, I had the mention of the Ideas Lab, which is an outreach facility predominantly to kids in schools and sometimes even before. So this spatial awareness of our environments is the key to spatial thinking. And this envelope on the right-hand side is actually the cover of a book which talks about geospatial curricula. It's using the famous painting of Vermeer where the geographer, that's the title of the painting, is looking out of the window, not because he or she is bored, but because of making the connection between the real world and the outside and the document, which in our case is a digital document, inside. So I had mentioned the term digital earth once before, and it was mentioned in the introduction by reference to the International Society of Digital Earth. And it's a term I increasingly use with some outreach and some communication because it doesn't use the syllable geo. Yeah, I was trained as a geographer. I identify as a geoinformatics person. But think about the silos. I don't want other people to think, well, that's GIS, that's a tool for the geo people. You do that, you do it well, you keep doing that, and maybe want to be left alone. This is important for everyone, and that's why I'm happily using this term digital earth for promoting our discipline a little bit more widely. Thank you.